and tracking down this room. That was brave of you. And so this is the finale of a project that started last January, and actually, technically started last March. It was kind of conceptualized last year. And so this is the master's project that I've been working on all of last year. It went through a programming process, a testing process, and finally a write-up, and I'm ready to show you everyone. So, you guys know me, I hope, but I'm part of Nina's lab here. I'm a master's student in computer science, specifically in human-computer interaction. And the research areas that I'm interested in particular are the integrated technologies, what's a kind of blanket term for what I'm specifically talking about is smart cars, smart homes, wearables, intelligent devices that have computer systems that allow more user interaction, and in particular software that kind of bridges this engineering device side and then the human side using design and behavioral science. And in particular, using software to make these smart devices much more impactful, much more accessible and efficient. And hopefully the project will kind of prove all of these points. A quick overview, presentation is going to be about 30 to 35 minutes. I'm going to start with a little bit of background on what are integrated technologies and how they run, how they're kind of influenced by emerging green energy sensibility. And the point of contact with these two are interfaces. I narrowed down to specific issues that the project addresses, and then next the project itself, the technical components of how it specifically addressed these issues, what are the components of the project, what was the approach, the conceptual and the practical approach to each of these. Technical challenges, of which there were many, but some of them that are very unique to a feedback system like this. Some of the more interesting challenges that I ran into, and the process of beta testing and the results, because the system had to work and had to prove that it worked. So I went through a process of beta testing, and some of the results from that study were very interesting in how I practiced this system was applied in real life and the effect of that. So to start with, what do cars mean to us? We're Americans, we drive a lot. We spend a lot of hours a day in the car. For a lot of us, they're modes of transportation, they're homes for some of us, they're expressions of our personality. And most of all, they're platforms for innovation in fields of engineering, in mechanical, electrical, industrial engineering, and fields of design, in the studies of usability that kind of look at human behavior and human needs. And they kind of, the usability studies kind of integrate, bring in the machine side to the human side. How is the human going to approach the cabin, the interior of the car, and what is their interaction going to be with a vehicle? And now they're actually becoming a platform for computer science. An example out here, as you can see, this is the interior. A lot of you will recognize this, the interior of a standard 1999 Toyota Camry, one of the most popular cars ever sold in the US. Pretty standard. All the gauges and dials out there are purely operational for the driver. The points of interaction are quite limited out here. And next, this is the interior of the Tesla Model S. Absolutely top of the line sort of platform for innovative vehicle technologies. Biggest feature here is a 17-inch screen, and this presents the point of contact for the driver with the vehicle suddenly expanded to include so much more than what is offered here. We have the user has a choice of displaying information, hiding information. Just the choice of information available to a driver is just run into the hundreds at the discretion of the manufacturer. And just so that we kind of move towards a little bit more consumer-friendly vehicles, this is the 2015 Toyota Camry. Still one of the most popular cars. but just across the 15-year span, you can see the evolution of driver and vehicle interaction. And if you give me a second, I will switch the display so that we can ignore these notifications.
Or turn the lights back.
Light up?
Oh, it'll come back on in a second.
Oh god, some of this. Maybe the top thing? Whatever feels like you can push it in. Oh, no.
Okay.
Well,
Okay, we're back.
Too late now.
So why is this relevant? The newer in-vehicle technologies are kind of becoming a focus of an emerging green energy industry, where we're able to target the driver inside the vehicle, not just focus on the efficiency of the vehicle itself, newer engines, electric engines, hybrid electric engines, but the second half of the equation, which is the actual human, the user of this technology that's sitting inside the car. So these interfaces are becoming a platform for feedback systems, particularly fuel efficiency and driving behavior feedback systems within the vehicle itself. So as we can see, our Tesla can, it's very common these days for cars to give us back information on what's our miles per gallon, what's our fuel efficiency, if you own one of these newer vehicles. So they're kind of embodying a kind of industrial and engineering and design shift towards feedback, fuel efficiency feedback systems. The problem with this is that the prevalence of smart cars is still really, really small. The vast majority of cars driven on the road today are the traditional, not dumb cars, but the non-smart cars, let's put it that way. And the accessibility to personal driving feedback is still very limited. So one of the issues that I wanted to address was bringing feedback to any vehicle possible. So, and the ideal platform for that is a mobile platform. Smartphone penetration is wide enough now that we can reasonably assume people, nearly everybody who has a car will also have a smartphone. And that way, by enabling feedback on a mobile system, we're able to bring feedback to any type of car that people are driving within reasonable limits. If you have a 1960s car, maybe not that successful. A second issue that we ran into was the style and design of the interfaces that are currently available on the market. Some of these are actually embedded in smart cars, and one of the issues with these is that they're very manufacturer specific. It's up to the company to design what kind of feedback is given to users and what are they going to present it in terms of, some of them are very numerical, as you can see in the bottom left. Some of them are a little bit more of an intuitive and emotional approach. So presumably the leaves get bigger, the tree grows as you drive better. But it's still, the approach is still in a very kind of intuitive way, not standardized or consistent. There's still a lot of questions about what's good feedback and what's bad feedback and what's the particular impact it's having. Is it actually having an impact on driving behavior, etc.
So are these apps or are these onboard dash displays or what?
These three are actually embedded into the screens of the car. So these are manufacturer installed apps. This is actually a mobile app. And I looked into how they calculate their fuel efficiency data, and what they're using is GPS and distance tracking to kind of ballpark how much fuel your car is using, how efficient you're being. And then of course this brings up the problem that fuel usage, it varies hugely per car and per engine. So an app like this will not necessarily be able to differentiate between a V4 and a V8 engine. And there's of course a huge difference in how much fuel these two are going to use up. So the specific issues I tried to address in the project are first, lack of accessibility, trying to bring feedback to users, and lack of clarity, trying to create a consistent, measurable system. Those chairs here. That we can kind of try to measure with real life users. In effect, actually trying to connect the concept of driving with specific impact or what are the particular consequences of this driving, And can we tap into a kind of motivation to change, a self-initiated behavior change, not just kind of feedback that tells the driver, well, your MPG is down right now, you should accelerate less, but present the information to the driver so that they can initiate behavior change on their own. And in fact, the theory behind it is that by removing a kind of clear idea of what is the personal impact of your driving, and removing a clear idea of the consequences, it limits the user's ability to motivation to change their driving behavior. Why was this a challenge? A feedback system like this would have to encompass many levels of thought. It had to combine design sensibilities. The technology had to be efficient and effective and work, and the scientific basis for the feedback also had to be sound. The choice of feedback to be given to the user had to be based in behavioral science principles, so that we know what type of feedback we're giving back to the user and what is the type of impact that we can measure. And of course, the engine data that is obtained from the vehicle itself has to be converted accurately. We want it to be accurate and keep our calculations as accurate as possible. Design-wise, the interface had to be as clear and communicative. Usability-wise, it had to be extremely easy to use. The barrier of effort had to be lowered so that you're actually helping people. You're not inhibiting people from using the app by making it difficult for them to view your driving feedback. As far as the technology goes, the app would have to span the entire stack of development, from front end, which is the layout of the screen, down to the very specific hardware systems that we're dealing with and kind of adapt to that situation, and the back end as well, the database where I would collect information on these drives. So one of the breakthroughs to can this system be created and done on a mobile platform came back from a bit of research into vehicle communication systems. It turns out vehicles, microcontrollers and systems and gauges in a vehicle communicate on a single communication line called the CAN bus, the controller area network. This main line of communication handles everything inside the car, but also can communicate to things outside the car via a communication port called onboard diagnostics. This little transmitter down here is actually able to plug into a car and in fact plug into this main communication line. So that way we're able to pass messages into and out of the vehicle system itself. This is the design of the OBD2 transmitter that was used in this project right here. And of course the OBD is Bluetooth enabled, which completes that final link to the mobile app itself. And the reason I use the OBD is that it's able to get very specific and accurate engine data, right out of the engine itself. So there's no compensating for variation in car size, make, model of the car, and type. It's actually just getting raw data out of the system. So the way this works is the mobile app will send messages to the transmitter via Bluetooth, which will then communicate this to the vehicle. Messages will return to the transmitter and then come back to the phone via Bluetooth. So for the user, it would be as simple as just connecting to the transmitter. If this transmitter is just plugged into the vehicle and it just needs to remain there, it's as simple as just connecting to this via Bluetooth as you would do for any other Bluetooth device. And that way, the app is able to open a line of communication to the vehicle and collect data from the engine as the drive progresses. Design-wise, these are the three screens of the app. There's a limited number of functionalities so that the focus is on the feedback given to the user, and as far as possible, user interaction is kept limited to a more retrospective feedback screen. This is a drive interface. This is just simply a data collection screen. And as you can see, the visual complexity kind of increases as the attention of the driver increases. This is for driving, so there's no feedback available here. the data calculated will pop up in a metric screen immediately after the conclusion of the drive. So this is presented as soon as the user is finished driving. They can look at the phone and see all their data adjacent to each other for instant comparisons. And the retrospective feedback screen is actually more complex, and we're able to put in a little bit more interactivity here to let the user engage with their data. And in this screen, they're able to view their accumulated feedback, their accumulated carbon emissions data across a series of time periods, and they're able to view this feedback over a day or a week or a month, and they're able to choose what type of metric they want to see this in. So they're able to view feedback immediately, or immediate impact, and retrospectively to have them engage in their performance and be able to build a sense of their performance across time. The structure of the application itself was designed to kind of handle a lot of complex functionalities going on at once. So for ease of use, I divided it into kind of 3 levels. The application level is simply the command structure of the app, which would initiate certain functions with each screen when the user passes between the screens. So data collection occurs in the drive screen. Immediate feedback, that is the calculation of the formulas that go into the data immediately present in the most recent drive is a metric screen, and retrospective feedback is actually in groups, not metric screen. The data level management system kind of had to deal with data coming out of the engine in raw hexadecimal format. It had to communicate down to embedded software where data was being passed back in bytes of hexadecimal. So the instantaneous data obtained from the engine was in hex, was parsed back into regular decimal format, and then converted into a specific metric back for view for the user. The memory management system took care of what the user was viewing at a particular time and storing it for later viewing. So there's an in-app memory storage system that stores session data in a particular drive. So that data is immediately accessible to the user. It's also stored externally for the user to access at any time. They can pull out their phone at any time and view the retrospective data. Part of the study also did data collection on the drives. So this was linked with a database on Amazon Web Servers. So the researcher that is me would also be able to see the accumulated data from users. The choice of feedback parameters was driven by a bit of research into behavioral science. One of the theories we used was Schwartz's norm activation model, which states that pro-environmental behavior is supported by awareness of concrete consequences. Basically, which told me to quantify the impacts, to give very specific feedback that this particular drive from point A to point B was X kilos of carbon, which corresponds to, let's say, Y gallons of gasoline used. And